Hello everybody. In this video we shall learn about rational expressions. As the name itself suggests that rational means we are going to deal with fractions of expressions, but we shall learn whether fractional expressions are same as rational expressions. So for that I will define fractional expressions. It is a quotient of two algebraic expressions. It is a quotient of two algebraic expressions. So now before giving examples of fractional expressions, I would like to define rational expressions and establish the difference between these two and give examples to both of them simultaneously. So now I will define rational expressions. It is a fractional expression. Throughout this video I will abbreviate fractional expression as FE and rational expressions as RE to avoid more writing. That is not a standard abbreviation followed in math. That is just my thing to avoid more writing. So it's a fractional expression in which both numerator and denominator are polynomials. So now you may wonder what is the difference between both the definitions. We can recall polynomials are nothing but sum of monomials, where monomials are of the form ax power k, where a will belong to set of all real numbers, that is a is a real number, and k will be a non-negative integer. A non-negative integer. That means there is a restriction on k. K cannot take fractional values. That means we are totally avoiding radicals. So polynomials do not have radicals over or fractional exponents over the variable. Hence, if we consider these examples like 2x over x minus 1, y minus 2 over y square plus 4, x cube minus x over x square minus 5x plus 6, and x divided by square root of x square plus 1. In all these examples, all are fractional expressions because each numerator and denominator is definitely an algebraic expression, but the last expression here is not a rational expression, and all these three are fractional as well as rational expressions. Why this is not a rational expression? Because we have a radical power over x. So the denominator is not a polynomial. And the definition, if you look at the definition carefully, it means that every rational expression is a fractional expression, but every fractional expression need not be a rational expression. For that, this is a very good example. So now is your quiz 1.4.1. Which of the following are rational expressions? So first one, square root of 2x divided by x plus 1. Second, 9 cube root of x square plus 8 plus x divided by cube root of x plus 3. Third, x of x plus 1 divided by x plus 1 the whole square. Now I shall define domain of an algebraic expression. So it can be just an expression, a polynomial or a fractional expression or a rational expression. So how shall we define the domain? It is the set of all real numbers that the variable is permitted to have. So I shall explain this while giving you examples. Before that, I guess you all remember set builder method that we discussed in the review video. We use that extensively when discussing about the domain of an algebraic expression. So now coming to the examples. First one, if I consider 1 over x, we know that in a fraction, we haven't defined a fraction where what if the denominator is 0. So when that case is not defined, x cannot take the value of 0. So therefore we are restricting x to the all real numbers except 0. So using set builder method, we will write domain of 1 over x as all those x such that x is not equal to 0. So now you can ask like whether writing x belonging to R is necessary or not. That is not necessary because in the definition itself you are allowed to take values from set of all real numbers. Therefore writing this would be a redundancy. So if I consider the next example, that is square root of x. Here again, when we were discussing radicals, I told you that negative roots, square roots are not defined because we are working in real domain. That is, we are working with set of all real numbers only as of now. So therefore, x in the above expression cannot take negative values. It cannot take negative real number as a value. Therefore, in that case, we are, if this is the real line, if you have 0 here, this is negative and this is positive, we are totally eliminating, we are totally eliminating the negative part. So but it includes 0 and the positive part. So how do we write the domain now? Domain of square root of x is nothing but set of all x such that x is always greater than or equal to 0. Now third one, if I consider 1 over square root of x, in this particular expression, we will apply both the restrictions of what we discussed in example 1 and 2. Because we have square root of x, that means the restriction of 2 applies here. X cannot take negative values, and square root of 0 is 0. That means there are all the chances of denominator becoming 0 which we haven't defined when x is 0. So we are eliminating in the real line 0 as well as negative numbers. So we are left with only positive numbers. So domain of 1 over root x will be x such that x is always greater than 0. We shall go to some complex problems which are some are picked up from your exercises. So first one, negative x to the power of 4 plus x cube plus 9x. Here we do not have square roots. Here we do not have this is just a polynomial. It's just an algebraic expression. We do not have fractions here. It is not a rational, it is a rational expression, but denominator is 1. So in this case, x can take any value. So domain of, if I write this to be a, domain of a will be equal to all those x such that x belongs to R. So that means it is not, this set is nothing but set of all real numbers. Next example, 2t square minus 5 divided by 3t plus 6. So this is a proper rational expression where denominator is, we do not know whether it is 1 or not. So denominator, we have a denominator here. So we should avoid the case where denominator becomes 0. So that means your 3t plus 6 should not be 0. So think of this number operated with this number 6. What gives you 0? It is negative 6. That is, if this number is negative 6. So 3t should not be negative 6. This implies 3t should not be negative 6. When can 3t be negative 6? When t can be negative 2. So t cannot take negative 2 as a value. So it doesn't matter what happens in the numerator, because a numerator can be 0. 0 by 1 is nothing but 0, or 0 by anything for that matter is 0. But 0 and 0 together, sorry, numerator and denominator together cannot be 0. To avoid this case, it is enough if we express or take out that value where the denominator is becoming 0. So in that case, t can take any real number as a value except negative 2. So if I write this expression as a by b, domain of a over b is nothing but all those t. Be careful with the variable. The given variable is t, not x here. T such that t is not equal to negative 2. Next example, this is exercise 14 in your book. Square root of 2x over x plus 1. This is an interesting example. You will understand why. Here again, this is a rational expression, and observe that you have square root as well as a denominator. So let us deal with denominator first. The denominator should not be 0. So x plus 1 should not be equal to 0. Think when x will be 0 when operated with 1. That would be when x is negative 1. So x should not be negative 1. And here we have a special case that numerator has square root. So square root of negative numbers, as explained before, is not defined. So x cannot even take negative values, negative real numbers as values. So x does not belong to negative integers. But minus 1 is already a negative integer. So you need not specify this condition while writing the domain specially. If you write this, that x does not belong to negative integers, or x is greater than or equal to 0, is enough. Therefore, domain of, that is the reason why I said this is a little interesting. If I write a over b, domain of a over b is nothing but all those x such that x is greater than or equal to 0. Okay, so your quiz 1.4.2 with suitable explanation. Find the domain of the following. First one, square root of x plus 1 divided by 2x plus 3. Second one, 3x divided by x square minus 1. Moving further, we learnt about factorizing trinomials and polynomials with perfect squares and cubes in the previous video of algebraic expressions. We shall use the same to simplify rational expressions now. Now we shall learn how to divide and cancel out common factors. The first process, we will learn what does it mean to cancel out common factors in a rational expression. That is defined as if A, B, C are polynomials. If we have a rational expression like this, AC over BC, you can cancel out C, so you will just have A and B. So what is actually the process that is leading to the name cancelling? It is nothing but AC by BC can be expressed as A over B times C over C. C divided by C is nothing but 1. So A over B is multiplied by 1 is nothing but A over B. This is the process that is happening here. So you need not write this process, which seems to be simple, but you prove all these things as you come to the higher level. So you can cancel it out directly. But it is not necessary that every time you can see this. You can see the common factor so clearly visible when you are given a rational expression that needs factoring. So now you understand why did you learn the factoring formulas or product formulas. Once you factor whether numerator and denominator, then you may or you may not see common factors. If you see common factors, you need to cancel it out. So let us do some examples. First one, x square minus 1 over x square plus x minus 2. So first, if I observe the numerator, it is of the form a square minus b square, because x square is a perfect square, 1 square is a perfect square. So where a will be x and b will be 1. Use the formula a square minus b square. What is it? It is nothing but a minus b times a plus b. If you use that, you will get a minus b is nothing but x minus 1 and a plus b is x plus 1, and the denominator is a trinomial. So first see that can you apply special factoring formula. For applying special factoring formula, your first term and last term must be perfect squares. They aren't perfect squares here. Therefore, you should understand that you need to apply trial and error method. So consider this last term. So 2 and factor out 2. You have, as 2 is a prime number, you just have 2 and 1 as factors. So you can express x as 2x minus x. So split the middle term in this manner. You will get this expression to be x square plus 2x minus x minus 2. If you simplify this further, the numerator is already factorized properly. Consider the first two terms of the denominator. There you have x to be common and you are left with x plus 2. And the third and fourth term, if you consider, you have negative 1 to be common. You are left with x plus 2. Now if you observe these two terms, you have x plus 2 as a common factor. So take it out using commutative rule and you will be left with x and negative 1. Now you can observe common factors in the numerator and the denominator, that is x minus 1. But you can say this is of the form CA divided by BC. That doesn't matter because multiplication is commutative as far as you are working with real domain or higher. That you learned it in your review video. So this is nothing but you can cancel out C now. What is your C? That is x minus 1 and x minus 1. You are just left with x plus 1 divided by x plus 2. Now if I consider, let us consider second example. 1 minus x square divided by x cube minus 1. Again, the numerator is of the form x square minus b square, but the values of a and b are interchanged. A is 1 and b is x. So use the formula a square minus b square. You will get it to be 1 minus x times 1 plus x, or x plus 1. It is one and the same. Divided by, observe the denominator, both x cube and 1 are perfect cubes. So you will apply the formula a cube minus b cube, which is nothing but a minus b times a square minus plus ab plus b square. If you expand the denominator using this formula, we will get where a is x and b is 1. If you expand it using the given formula, you will get it to be x minus 1 times a square is x square plus a into b is x into 1, that is just x, and b square is 1 square, that is just 1. Okay, further simplification of this. Now it is not very clear that you can see common factors, but if you apply commutative rule to this and take out -1 as common, how do you take out -1 as common? 1 is nothing but -1 times -1. Okay, 1 is nothing but -1 times -1. Plus minus x is nothing but x times -1. Correct? So in this term and in this term, you have -1 common. You can definitely take it out. I will retain the denominator as it is. If you take that out, you will have -1 plus x times x plus 1 divided by x minus 1 times x square plus x plus 1. Addition is commutative, therefore you have x minus 1 to be same as x minus 1 in the denominator. Now you can cancel out the common factors and you are just left with negative of x plus 1 divided by x square plus x plus 1. You need to be careful, check whether you can further divide or simplify the denominator. I guess you cannot do it because this is definitely a trinomial and the first two terms are squares, but the middle term doesn't seem to be in the form of 2ab format to apply a plus b whole square, or you cannot express 1 as factors that when added or subtracted gives you back 1x. So this is the maximum way or maximum step up to which we can simplify. Now I shall give you some quiz questions. 1.4.3, simplify. First one, 4 of x square minus 1 divided by 12 of x plus 2 of x minus 1. Second, x minus 3 the whole cube divided by 3x square minus 8x minus 3. You just need to factorize the numerator and the denominator and cancel out if there are common factors. And third one, this is a bit lengthy and little tricky. It is just that I'm including many terms here. You should be very careful with the signs, brackets, and the process. Times negative 2x divided by whole divided by x square minus 1 the whole to the power of 4. Yeah. So be careful with the sign and there are common factors. You can cancel out some common factors. Think about it and solve it. Okay, moving further, we learned about factoring rational expressions and cancelling out common factors. Now we shall learn how to multiply and divide rational expressions. Um, First, we shall learn the process of multiplying rational expressions. To define one such process, if I consider A, B, C, D being polynomials, and if you are given two rational expressions that need to be multiplied, it is same as multiplying numerators and denominators separately and expressing them like this. Here the process is you are multiplying the numerators and denominators. We shall go and learn by examples. If I consider x square plus 2x minus 3 divided by x square plus 8x plus 16 times 3x plus 12 divided by x minus 1. Don't go into the process of applying this rule directly. See if you can factorize each expression, rational expression separately and cancel out if there are common factors. That would make our multiplication process very simple. So if I look at the numerator of the first expression, it is a trinomial. So and 3 can be written as 3 into 1 because it's a prime number. So if you express 2x as 3x minus x using these factors, you can split the middle term into the way expressed here. That would give me x square plus 3x minus x minus 3 divided by, and the denominator is a trinomial, but you can see the first term and the last term are squares. And if you consider a to be x, and what is the number that squared twice gives us 16, that is 4, and b to be 4, can you express the middle term as 2ab? Let's check it. 2 times x is 2x times 4 is 8x. Of course, definitely it is 8x in the middle term. So you can apply the formula a plus b the whole square. That is the special product formula. I am repeating again and again. You need to learn all the formulas by heart, because you may use a formulated list while during exams, during these periods, because you have virtual exams. But that doesn't help if you have in-class exams, because you are not allowed to use any formula list or any calculator. So you should learn all the formulas by heart and all the concepts too. As you can observe, if you are very keen in observing, you can see that we are using every little concept that we have learned so far. So that's why some students find math a little difficult, because they tend to ignore certain concepts that may be applied in future lessons that they learn. Hence, it is very important for you all to learn all the concepts properly and see where you can apply it, and that would lead to a better learning. Okay, now coming back to the lesson, we can apply a plus b the whole square, where a is x and b is 4. So the denominator becomes x plus 4 the whole square. Okay, and this one, second expression, you can see the numerator, we have 3 common. You can write it to be x plus 4 divided by x minus 1. Okay, we shall further simplify the numerator of the first expression. If I consider the first two terms here, that would give me x common and x plus 3 written, and the last two terms -1 common and x plus 3. divided by x plus 4 the whole square into 3 of x plus 4 divided by x minus 1. Now do the process again. In the first two terms x plus 3 is common. You are left with x minus 1, and this would be x plus 4 the whole square times 3 of x plus 4 divided by x minus 1. Now carry out the process of multiplication that we discussed above. This process. Now you can carry out this process. That would give us, multiply all the numerators, terms in the numerator, x plus 3 times x minus 1 times 3 times, x plus 4 divided by x plus 4 the whole square times x minus 1. One thing is very clear here. We have x minus 1 and x minus 1 as a common factor in both the numerator and denominator. So carry on with the process of cancelling them. And you can see here you have x plus 4 common. Before I cancel out, I would like to expand the denominator to emphasize the process of factoring it completely before cancelling. This is a very simple thing. You can do it without cancelling, but if you have some complicated equations, this process really helps, trust me. So now you can cancel the numerator and the denominator. Now you are just left with 3 of x plus 3 divided by x plus 4. Okay, here is another example that I will solve for you, which is a little difficult. This is number 32 in your book. X square plus 2xy plus y square. So now if I consider y square, oh sorry, yeah, I'm sorry, this is not it. Yeah, we are talking about multiplying rational expressions. So this continues, divided by x square minus y square times 2x square minus xy minus y square divided by x square minus xy minus y square. Okay. So now if you consider this term, here you can see x square and y square are perfect squares. So if you consider a to be x and b to be y, can you express the middle term as 2ab? Of course you can. It is nothing but 2xy. So you can apply again here a plus b whole square formula. I will do that. So that will give us x plus y the whole square formula. And the denominator is of the form a square minus b square. Apply the special product formula for a being x and b being y. You will get it to be x minus y times x plus y. Now going into the simplification of the second expression, if we observe here, this is not a perfect square, so we cannot use a special product formula. Consider the trial and error method. You will consider 2y square. 2y square can be expressed as 2y times y, which where negative xy can be written as, how can you write it? 2 negative 2xy minus xy. So if you split the middle term in this manner, we get the numerator to be 2x square minus 2xy minus plus xy, this is plus xy minus y square divided by, the same thing applies to The denominator also x square. Can we apply it for the denominator? Yeah, can we? Y square is y and y. That is the only thing that we can do. Yeah, we cannot apply that to the denominator, and we cannot also apply the product formula, so we are just left with this. Yeah, we are just left with this. So now what happens? This would be x plus y the whole square divided by x minus y times x plus y, or I will write the numerator to be x plus y times x plus y. And now the numerator here will reduce to you can check this by solving x minus y times 2x plus y divided by x minus 2y times x plus retain your denominator as it is. That would give me x square minus xy minus y square. I feel I'm right. Okay, so now now you can see x plus y and x plus y are common. X plus y divided by x minus y times x minus y of 2x plus y divided by x square minus xy minus y square. So now apply the multiplication rule. Multiply the numerators and the denominators separately. X plus y times x minus y times 2x plus y divided by x minus y times x square minus xy minus y square. Now you can observe x minus y and x minus y are common, so you are just left with x plus y times 2x plus y divided by x square minus xy minus y square. So this is the final stage up to which we can simplify it. Okay, now your quiz. Uh, 1.4.4 multiply the rational expressions. Multiply the rational expressions. First one, x square minus x minus 6 divided by x square plus 2x times x cube plus x square divided by x square minus 2x minus 3. Second, x square minus 25 divided by x square minus 16 times x plus 4 divided by x plus 5. Okay, I'll stop this video here. I will continue in the next video. I will be discussing about adding and subtracting rational expressions and dividing rational expressions. I don't want to pile up everything in a single video. I am planning to work out all the even numbered problems in my office hours. I want you all to attend my office hours, because you can see that if you are following the textbook, you can see that I'm working out some of the examples and most of the even number problems in the video, and I'm planning to work those even number problems in the office hours as well, and signing some quiz problems. So you will not be getting similar or exactly the same questions that I have worked here. You will be getting brand new questions where you need to apply the concepts that we all have discussed till so far in your exams. So that is the reason why you need to attend office hours, so that will add on to your practice. We can discuss, and I will be like live and there for your help. I cannot do that in a video. I will not understand what are the doubts that you are getting. I will not understand how far you are learning is progressing. So instead of performing bad in your first exam, I suggest you to attend office hours, practice as many as questions. Let us do it together. That will help both of us, uh, and that will lead to a better learning. So see you all in my office hours, and do follow up future videos.